this is Pete Singer, editor of Solid State Technology. I'm here at SEMICON West 2018. I'm talking to Fram Akiki, who's the Vice President of Electronics Industry Strategy at Siemens. Hi Fram, how are you?
Very good. How are you doing today, Pete?
Great. So I wanted to talk to you a little bit about digitization of your whole life, essentially, and kind of the electronics industry from the design on through manufacturing. And just wondered, if you could give us your perspective on how you see that evolving.
Yeah, it's a great question, Pete. I was talking to someone the other day about my own personal career and kind of how it's evolved. And I started back with IBM in the early 80s. Wow. Spent 20 years with them, mostly in the compute side of the business. Then spent 12 years with Qualcomm in what I call the connected era. And now with Siemens, I'm diving in headfirst into this whole digital transformation piece. So, and it's kind of interesting because my career has sort of modeled what's also happened in the industry. This whole compute, with mainframes and personal computers to connected with smartphones, and now the digital era. And it's really driven out of necessity, right? We've got things like increased complexity. We've got, and on the complexity front, as an example, the CEO of Toyota recently mentioned that to get to a level 5 autonomous vehicle, you have to drive something like 8 billion miles of testing, right, to get to the safety levels and whatnot for that. And obviously you can't do that using what I call business as usual or the old legacy type models, right? So this is kind of what's driving this whole digital transformation, is being able to develop digital models that will allow us to do simulation such that we can get to the kind of levels that you can't get through just normal physical means, right? Mm-hmm. And I think this whole concept around the digital transformation, from a Siemens perspective, we're looking at it in sort of 3 pieces, if you will. There's the upfront, what we call the ideation piece. So think of design, for example. We have the realization piece, which is the manufacturing part, and then the utilization piece, which includes everything from lifecycle management to the analytics and machine learning that you do across that whole process. And we see the digital transformation, this concept around model-based engineering, really playing a role in each one of those steps. The Mentor acquisition that we've made has been a very important one from the Siemens side, because it now allows us to not only play through each of those 3 steps, but more importantly, they bring to us a mindset, if you will, and a skill set around this model-based engineering. So some of the things that we are doing today in system level design and development of models, it's very analogous to what we've been doing on semiconductor design for decades, right? Mm-hmm. Because people have talked about first time right when you design a chip and you can't afford to keep doing spins and whatnot. We're taking that mindset from the Mentor acquisition, right, and bringing it to the system level. And of course, we're also going the other direction where we take the system knowledge that Siemens has, right, and bringing it down into Mentor to do things like functional safety for automotive applications, where you really need to look at the idea of behavioral models and whatnot to be able to look at things end to end for critical applications. So okay. Lots of exciting stuff.
Absolutely.
We're, like I said, we're looking forward to all of the, not only all the possibilities and solutions that this digital transformation is going to do, but we also feel like it's going to even open up sort of new business models and business opportunities. So it's going to be a transformation not only on the product side, but we think even on the service and business model side.
Yeah, I would think so. Well, we're hearing a lot about smart manufacturing here at the show, and it seems like in Industry 4.0 and using cloud computing and data sharing and all these great things, but it seems like the semiconductor industry has some kind of legacy issues where they don't want to share IP with their vendors, and things like that. Do you see that? Does that some obstacles that can be overcome easily, or is there more work to do?
Well, there's always more work to do, obviously. We're fortunate from a Siemens perspective, right, where we have a very open system policy, right? So we go in and we work with customers, both in what I would call greenfield type situations, right, where they say, hey, we've got both the opportunity and the ability here to just do things from the ground up. But more often than not, what you're doing is you're going into these sort of brownfield opportunities, right? A lot of legacy systems in there. People don't want to touch anything because it works, right? So there's always this nervousness about, okay, so, are you sure what you're going to put on top of our legacy systems, right, is not going to break something? That's always the first question. And then, you get to the second piece where you say, okay, it's not going to break it, but here's the additional value that it's going to provide, right? And certainly in semiconductor manufacturing, there's a lot of things around smart manufacturing that are sort of evolving today, right? There's the pieces of things that I call, again, business as usual. People are always looking at how do I improve my yields, my cycle times, right? The usual operational stuff. But with the advent of things like IoT, the automotive industries, and all the things that the electronic industry are driving onto the semiconductor, you're seeing some changes. And some of these changes, for example, are things like more SKUs, more personalized products, this idea of lot size 1, right? Which can be a real big challenge for a semiconductor company, a manufacturer. Because usually they're used to single part number, high volume, I know how to do yield learning, I know how to get that out, I get it perfect, I get it right, and it's just wash, rinse, and repeat. Now, when you're telling me I have to generate all these different SKUs, they may have different layouts, sensitivities, etc., that becomes a challenge. And that's where the idea of smart manufacturing comes into play of how do you handle the logistics, the yield learning, all of this around doing personalized products. So that's some of the areas where we're investing in and helping our customers to be able to excel in that environment, because that's what they're being driven by what I call the broader electronic industry to do. Right? And it's an interesting thing, right? Because the electronic industry has historically driven the semiconductor industry.
True.
But there's always been sort of a black box kind of scenario, right? The semiconductor companies would deliver this component into the electronics and say, here's your spec, trust me, it works. And now, I mentioned earlier functional safety, where that's not going to be good enough, right? They're actually going to want to see something a little bit more around behavioral models and things around this that the manufacturers are going to have to provide. And that's where this sort of end-to-end digital thread comes into play, and that's why we look at it from, as I mentioned earlier, ideation, realization, utilization, and how to tie it all together in a digital thread.
Okay.
So,
well, thanks for your insights.
Yeah,
Appreciate it.
thank you, Pete.
Thank you.
Yeah, have a great show.
You too.